example, in y-axis. Therefore, we are to use the third equilibrium, the third equation of equilibrium, which is the summation of moment. Now, the question is, asa ta nga point mag-take og moment? So, of course, if mag-take ta og moment, no, we are to take summation of moment at the point where naatay ma-eliminate na unknown force. Kaya para ma-compute nato directly ang magnitude no sa isa ka unknown nga variable or unknown nga force. So, if you notice, na ay point A, no? So, at that point, pwede ta mag-sum up of moment since at that point, dara man muagin or mo-pass through ang direction sa ato ang force R2. So, meaning, kung mag-sum up to moment at point A, ma-eliminate si R2 as well as si P. Kaya niagi man siya dara na point. Kaya di ba basically or technically, our equation no, for moment is just force times distance. But distance here refers to the perpendicular distance na of this force padulong sa moment of consideration or the point of consideration sa ang moment. So, basically, any force that is passing through at the point of consideration, kung asa ta nag-take of moment, then that force will just be eliminated or that will just be equal to zero. Since, let's say, for example, mag-take ta og moment at point A. So, your force R2, pila man iyang distance kang point A. So, naara man siya kang point A, meaning zero lang ang iyang perpendicular distance, di ba? So, any magnitude or regardless of the magnitude na of R2 multiplied by 0, so mag-zero lang yapon na siya, class. That's why we have this principle no in moment that any force that is acting through the point of consideration sa imong moment is just equal to zero or they will just be eliminated. Okay? So, as well as at this point, pwede sa ka mag-take of moment at this point no since ma-eliminate man si R1 o si P. Kay at this point, dari man nag-act si P. So, ma-eliminate lang gihapon siya. So, with that being said, no, sige, let's take summation of moment at point A. They will just be eliminated. So, we are to use the third equilibrium, the third equation of equilibrium, which is the as positive. This point, we have, okay, what are the forces involved sa to ang analysis? So, at point A, so, CW, no? So, the weight of the object, which is 1,000 pounds, and it will create, unsa man class, sige.
5.
No, iyahang rotation with respect to point A, is it counterclockwise or clockwise rotation ang ma-create ni W?
Counterclockwise.
Okay, very good. And then how about si REF, si red na to na force? So is it counterclockwise or clockwise with respect to point A?
Counter.
Yes, sir.
Okay, very good ha. Okay, how about si R1? Clockwise or counterclockwise?
Clockwise, sir.
Okay, very good. At least, no, nga, na sabtan niyo na concept. So, with that, no, unsa ganito, si W is counterclockwise, right? So, positive sign convention since atong assumption is summation of moment at point A equal to 0 and counterclockwise ang positive. So, any counterclockwise na nga rotation, so positive na siya nga force, ha? So, 1,000 times iyang moment arm padulong kang point A is 5 feet, no? So, nara siya. So, times 5. Then, si REF, which is 250 ang magnitude, no? So, REF, padulong kang point A, iyahang perpendicular distance is just 1 foot, right? Since from the ground, padulong sa imong center of gravity sa object, you have 3 feet pa daw. And then from the ground, you have 2 feet, no? Padulong kang point A. Therefore, iyahang distance, no? From the center of gravity of the object, padulong kang point A is 1 foot na lang. And positive sign convention since counterclockwise gyapon ang mag-create ni REF, no? And then unsa pa man si R1. So R1 times moment arm niya, no? So 'di ba always remember your class ha nga ang distance dapat is perpendicular, no? Ang um iyang distance or iyang moment arm padulong sa iyong point of consideration. So regardless of the orientation sa imong force. So let's say na atay force nga acting sa to ang center of gravity in this manner. So if you are to take the perpendicular distance dapat kani ang ato ang pangitaon, no? Ana siya. So ako lang ni siyang gi-recap no sa concept ni moment para natay refresher. So kani siya nga distance sa to ang pangitaon class, no? That is why masayon or nag-exist tong principle sa to ang Varignano theorem nga kuan nato siya into i-resolve nato siya into its components, no? Kay mas dali man pangitaon ni siya nga distance and as well as this one nga distance compared sa kaning perpendicular distance mo inclined force. Okay? So that is why or mo na atong reason nganong gina-resolve na to into x and y components. Most likely ang ato ang inclined nga forces para dali ra gyud pangitaon na iyang perpendicular distance padulong sa taong point of consideration. So okay, R1 padulong kang point A is just 10 feet, right? So negative since it will create a clockwise rotation with respect to point A. Oops, R1 guys, sorry. This is R1. So unknown pa, no? So as is or i-represent lang nato siya no as variable R1 times moment arm niya is 10 feet. Okay? So we now have the RF, W, and R1. So kinsa pa man na force, dapat si friction force, no? So gihatag man siya as resultant na force which is 20 pounds by the way. So padulong kang point A, you have 2 feet no ang yang moment arm and then direction. So it will create clockwise rotation as well. So negative sign convention. So minus 20 times 2 equal to 0. No, wala naman lain force nga maka-create og moment no with respect to point A. So in this equation, isa na lang dayo na ato ang unknown variable, right? Meaning, makompute na nato ang R1. And how much is R1? You have 1,000 times 5 plus 250 times 1 minus 20 times 2 all over 10. 521 pounds si R1. Nahiwi siya. Anyway, R1 na to is equal to 521 pounds. Okay? So, na-compute na nato si P, si R1. So, sa ato ang problem or situation 1, isa na lang ang ato ang problema, no? Si R2 na lang. But, remember that on y-axis, di ba, naadara si R2. So, R1 is obtained already. So, if mag-summation ta og moment at y-axis, makompute na nato si R2, no? Kay the components of forces on y-axis is just si R1, si weight of the object, and as well as si R2. So, sila lang tulo, di ba? And we have the weight of the object and also na-compute na nato ang R1. Therefore, na-compute na nato directly si R2. So, R1, which is upward direction, so 521 minus si weight, no? W. Kay downward direction man. So, this is positive ang upward direction. And then, plus si R2, mga upward direction also. So, equal to 0. Therefore, R2 is equal to 1,000 minus 521. That is 479 pounds. Okay? So basically, that's it now for our situation 1. R1 is equal to 521 pounds, R2 is equal to 479 pounds, and the magnitude no, of force P is equal to 270 pounds. So therefore, no, the magnitude of your force P must be equal to 270 pounds lang no, to achieve or to obtain this dynamic equilibrium na state sa ato ang moving object. Excuse me. I'd like to ask the class if naabang mo kadunggan nga audio or background na noise.
Last,
Naa?
yes.
Okay. So, ga-overlap di ay ang kuan audio sa mga seminar. Anyway,
Dili man kayo nga naka-concert ko so.
okay, very good. At least no, dili ra ta siya inana ka disturbo kung may nawon. Di siya ko so okay. Very good at least. Okay, sige. So, let's proceed with situation 2. No? Okay, by the way, no? So, basically, this is for the dynamic equilibrium no, for rectilinear translation. So, how about the curvilinear translation? So, we already know that the condition of dynamic equilibrium can be obtained by applying the inertia force, right? With magnitude weight over gravity times the acceleration of the body. So recall from our curvilinear translation nga discussion that 'di ba atong gina-resolve into x and y component ang acceleration para much easier for us to compute for the problem, no? Or if what is asked in the problem. So 'di ba ato siyang gina-resolve into components. So if we have x and y components, no, or the rectangular components of our acceleration, which we have discussed already from curvilinear translation nga discussion. We also have what we call the normal and tangential acceleration, or the normal and tangential component of acceleration. So basically, it's just the same with x and y component no, or rectangular components. It's just that for the normal component of acceleration, we have acceleration is equal to v squared over the radius. And for the tangential acceleration or tangential component of acceleration is dv over dt. So, di ba, dynamic equilibrium can be obtained by applying this reverse effective na force with magnitude na weight over gravity times acceleration. And then, if we are to apply this concept no sa ato ang curvilinear translation nga condition, then ato po na siyang i-resolve no into normal and tangential nga component. So from equation nga weight over gravity times acceleration, so this will have an or the normal component and tangential component. And then substitute lang dahil na class ang formula or equation for the normal component of acceleration. That's why nahimo na siyang summation of forces on normal axis is equal to weight over gravity times v squared over r. And then for the summation of forces na on tangential axis is just equal to weight over gravity times the um, tangential acceleration. But basically, this is just weight over gravity times an. No? Ana lang siya class. So, sige. So, to illustrate or to understand or to apply this concept, no, let's take a look at sample problem number 2, situation 2. So, you have a bulb, no, of weight W is moving with a constant velocity V in a horizontal plane at the end of a cord of length L. So, the string generates a cone while in motion. So, okay, ano yung siya na itabo class? So, I hope masabtan ang figure, no? We have a string daw po, no. So, this is actually a pendulum. So, ang bob, pasabot aning bob class, no, mo na siya to makita bitaw nga weight or nga object at the end of a string. So, isa ka pendulum, kanang mura o nagpabug-at bitaw sa iya ha, para maka-create siya o motion or momentum, para maka-generate siya og momentum, no. So, what happens here is that ang bob, no, naa siya circular nga movement or naa siya yaha ay rotation, no. So, if magtuyok-tuyok lang na ang bob, so maka-create yun siya definitely og conical no nga pendulum. So, let's say muni ang iyang support. So, if naa siya motion nga circular, so at any point, anak kibali siya, no, ang string. So, mo ni siya, murag i-represent lang siya in one string dayon. Okay? So, ana mahitabo. Ang motion sa to ang bulb is circular. So, yeah, it states here no, that the system is called a conical pendulum. So, it is required to determine the tension in the supporting cord. So, si T, no, tension sa cord. And then, the inclination with the vertical axis. So, the angle of inclination no, with the vertical axis. And the time to complete one revolution. Sige. So, how do we compute for these unknown variables, no? So if we are to look at the forces no acting at our object, which is in this case is kanisi bob, kanang bob, you have the tension force of the cord, and then iyahang normal component nga acceleration and iyahang weight which is acting downward. So mo niya itong ma-create nga force polygon class, no, the weight of the bob, and then iyahang so okay, so we have this our angle of inclination class, no. So ako lang i-enlarge ang force polygon no, that is acting on our bob class. So naano siya given datas actually. So the weight of the bob daw kuno is 100 pounds, and then the velocity no of the bob is 8.03 feet per second, and then the length of the cord is 18 inches. So, these are the data no, sa ato ang problem. Sige, so, if we are to relate, wait, the angle of inclination, no? Kung pahitaon na to na siya, so we don't have data for T. No, wala tayo given data for T, which is one of the objective na to siya diri sa to ang problem. So, ato ni relate ang opposite and adjacent no nga side sa ato ang angle of inclination, since W is given man, and we also have G since that is constant, and then velocity is given also. So as much as possible mulikay ta sa or rather kung magkuha tag relationship, so ang ato ang kuhaon is katong naay mga existing data nga given, no. So of course dili sa nato gamiton si T since wala man tay data for that. And ang ato ang objective is kuhaon sa ang angle of inclination. So, sige, opposite and adjacent na with respect to the angle of inclination, meaning tangent function ang ato ang gamiton, right? Since opposite and adjacent, no, from sa katowa, so tangent function ang ato ang gamiton. So, tangent theta is equal to opposite of your angle is the weight over gravity times v squared over r all over the adjacent, no, which is CW. So um, supplying the data no, sa atong equation, you have W is equal to 100, right? Then gravity. So 32.2 gyapon natong gamiton na value since we are in English system pa gyapon. And then velocity is 8.03 squared, tama? Okay. Divide by radius. So we don't know the radius no of our rotation. Then W is 100 pounds lang, no? So wala ta kabalo sa data sa ato ang radius, no kani siya. But kuhaan ta na siya og relationship later, no? So ato sa ni siyang i-simplify. So you have tangent angle theta equal to, so this is just 5 over 1 times 8.03 squared all over. So this triangle no is from the forces no or from the force polygon nga atong na-create using the forces that is acting on our object nga bob, di ba? So maka-generate ta or makakuha ta og another relationship actually by relating this another triangle which is the actual chord no or the length sa ato ang chord and then the vertical height and also the radius no of the rotation. So i-relate na ang radius of the rotation. So if we have this triangle, so ako lang siyang i-draw here. So this is the vertical height, then the radius and your length of the chord, no? In which given siya, which is 18 inches. So if this is 18 inches, so ato lang siya i-convert into feet. Kaya para compatible no ang ato ang units sa ato ang problem. So if we convert to in terms of feet, so may mo na siyang 1.5 feet, right? And this is our angle of inclination. So if kuan pa ni siya og angle of inclination, of course, dili na to gamiton, no? Or dili na to siya i-relate sa height. Ano man, wala man tayo data for height. So, gamiton na to ang existing data nga length of the chord, which is 1.5 feet. No? Then, i-relate na to sa radius kay atong objective is makakuha ta og expression baka ha or equation or value no for the radius. So, radius and kaning length sa chord. So radius is opposite no sa imong angle of inclination and then 1.5 feet is your hypotenuse ani nga triangle. Therefore, from sa katawa, opposite and hypotenuse, so sine function ato ang gamiton. So sine function of angle theta is equal to opposite nga si radius divided by the hypotenuse nga 1.5 feet. Therefore, your radius is equal to 1.5 of sine angle theta. Okay? And this expression class no for radius, ato na siyang i-substitute here sa atong equation. So this becomes tangent theta is equal to 5 over 161 times 8.03 squared all over the radius na 1.5 sine angle theta. Alright? So, with this equation class, no, actually, maka-compute na mo or maka-obtain na mo og value sa ato ang angle theta. So, if i-input ninyo ni sa calculator, si tangent theta is equal to 5 over 161 multiplied by 8.03 squared all over 1.5 of sine theta, mahatag og value si calculator. But I think dugay siya, no, maka-generate og or makahatag og value. So, ato na lang siyang i-simplify. So, how do we simplify this one? So, atong goal or atong objective is isa lang ka trigonometric function ang ato ang makita no, sa equation. So, unsaon nato pag-relate si tangent and si sine. So, recall no, from trigonometry, that tangent function is just also equal to sine function all over cosine function. Okay? So, equal now to 5 over, wait, let me simplify this further, kaning expression, ang right side. So, 5 over 161 multiplied by 8.03 squared all over 1.5. You have 1.335. 1.335 all over sine theta. And then cross multiply. So we have this equation, no? Resulting equation is sine squared theta is equal to 1.335 cosine theta. So duha lang yapon ka trigonometric function atong nakita, no? But remember, um, recall from trigonometry again, no? One of the trigonometric identities or what we call the Pythagorean identity is, diba, si sine squared x plus cosine squared x is equal to 1. Diba, we have this identity from trigonometry. So, if we express na to ang sine squared x in terms of cosine, so we will have this expression, sine squared x is equal to 1 minus cosine squared x. So, if ato ni siyang gamiton, no, nga relationship, so we are to substitute the equation or the expression for sine squared x. So, mahimo ni siyang 1 minus cosine squared theta is equal to 1.335 cosine theta. So, isa na lang ka trigonometric function ang ato ang makita, no? Which is si cosine na lang. And if I were to arrange this one into standard form of quadratic equation, since this is in quadratic na, may mo ni siyang um, cosine squared theta, oops, plus 1.335 cosine theta minus 1 is equal to 0. Therefore, angle theta is, pila man ni siya? Angle theta is just equal to 57.669 degrees. So, therefore, nakuha na nato na or na-complete na nato ang angle of inclination sa ato ang chord. Right? So, we have the angle of inclination. So, how about the tension, no, in the supporting cord? How do we compute for the tension in the supporting cord? So, if we are to relate that one, no, into our force polygon, makita nato si tension. And how do we relate tension? So, hypotenuse and sige, gamitan nato si AN gihapon, no? So, si WG over, um, yeah, WG times the quantity of V squared over R. So, opposite and hypotenuse. So, sine function lang gihapon ang ato ang gamiton. So, from force polygon, you have sine function or sine of angle theta is equal to the opposite over the hypotenuse, no? Which is si T. Tension siya. So, substituting the data, so you have sine of angle theta, which is, angle theta is 57.669 equal to weight is 100. Tama ba? Weight, oh yeah, 100 divided by the gravity na 32.2 times the velocity, which is 8.03 squared all over the, okay, radius, no, we don't have an exact value for radius, but actually, makompute nato siya if i-solve nato siya, no, or i-substitute nato ang angle theta nato sa equation ni radius na 1.5 sine theta. So, ato na lang siyang as is 1.5 sine of 57.669 all over T, tension, no, which is unknown. Therefore, makompute na to ang tension, right? Since siya raman ang unknown variable sa itong equation. So that is 100 divided by 32.2 multiplied by the quantity of 8.03 squared over 1.5 sine of 57.669 all over sine of 57.669. So tension therefore is equal to 186.982 pounds. Okay? So by the way, class, no, um, pwede po, di ba, sine function mo na itong gigamit. So if dili po ka gusto nga sine function ang gamiton, pwede po nga cosine, right? Since given man ang ato ang W. So if cosine function, may tabuan na is, di ba, cosine theta is equal to adjacent, which is si W, divided by T, which is much much shorter na solution, right? So it's just 100 divided by T. Then cosine or tension is equal to weight, which is 100 divided by cosine of 57.669. So you will arrive at the same answer lang yapon for tension. So pwede rasan na siya, class. Anyway, so okay, we have computed for the angle of inclination as well as for the tension in the cord. Therefore, isa na lang ang ato ang remaining problem, no, for situation 2, which is the time to complete one revolution. So how do we compute for time? So time is gold. We have this, ay sa tara, dari na lang. Um, di ba, if velocity is equal to distance or displacement rather, no, displacement over time, which, um, and di ba, we have this equation, simple equation for velocity. So velocity is given, no, sa bob, which is rotation or circular ang iyahang direction. So velocity is equal to 8.03 feet per seconds. Then we are to compute for time t. Kani siya. So if velocity is given, time is to be computed. So si S ang atong problema, no, or ang iyahang distance traveled sa imong object. But dili mabalaka since sa problem it states here that um it needs, or we need to compute that time to complete one revolution. So when we say one revolution, di ba isa katuyukan? Isa katuyukan. So if one revolution lang or isa lang katuyukan, so that only refers to the circumference of your rotation or of your circle, no? Circumference of a circle is 2 pi r, right? So if we are to use this relationship, no, or equation for circumference as the distance traveled by our object, so velocity is, Ma'am Carl, magklase ako kadali, ma'am. Tiwason lang ako. Kuno. Thank you, Ma'am Carl. Um, okay, so sige, asan na ta? Okay, so if the distance traveled, no, by our object is 1 full revolution or one revolution. So circumference lang sa circle ang iyang distance traveled. So velocity is given by 8.03, right? And then distance traveled is 2 pi r divided by time. So 2 pi times radius is 1.5 of sine 57.669 degrees, right? Divide by time. So with this, makompute na nato si time. No? Kaya siya naman na yun ang unknown variable. Therefore, time is equal to pila man na siya class. So it will take 0.992 seconds to complete one revolution no, sa ato ang pendulum. Okay? So, I think that's it na for this session. So, end na. Sa PowerPoint, no, end na daw. So, any questions, class na or clarifications before ta mo i-dismiss? So, by the way, mag-attendance that sa di ay no? So, wala yung concern class or question? Wait, today is, isa pa karon? Wait, isa to? May 17 no? May 17. CE2L. Okay, asa, natin nag-raise sa hand. Nay, clarification.
Sir,
Yes.
sobrang gyapon ng pagkuha sa conservat data, sir.
Again, di na ko maklaro kay, sa to?
Shift sobrang gyapon yung pagkuha sa conserv
Ah,
angle data.
oo, yes, yes. Pwede ra. So, any other concerns? CE2N. Wait, asan yung attendance class na wala siya? Wait ha. Okay. So, if you have questions or concerns, pwede ra nga mag-raise hand while gakuanta, ga-attendance. So, May 17. So, say present if you are here sa meet. Aberin Monique. Abrenica Hana.
Present, sir.
Asebar Maria Christine.
Present, sir.
Baconga Lloyd Vincent.
Present, sir.
Bastatas Joby. Bayotas Monique. Beniga Janya Rose.
Present, sir.
Okay. Bonglay Joey.
Sir,
Kailing Joby.
Present, sir.
Conar Dondi. Flores John Aiki. Leoren Jeffrey James.
Present, sir.
Malagamba Christian Clint. Medalya Rosel. Mariales Joyce.
Present, sir.
Mugo Ryan Van. Nahia Lendi. Nesperos Paul Vance.
present, sir.
Oclarit Eliza Nicole. Ortiz Lord Vincent.
Present, sir.
Pakana German Martin.
Present, sir.
Perihan Yasriel Vincent. Podadera Kiro.
Present, sir.
Sakwan Arlejen.
Present, sir.
Saging Jason.
Question